Have you ever gone to the store to see that there are things on sale? This often happens because when people try to sell something, first you try to sell for a high price and you see if people will buy. And if not, you lower the price. Here's a question 8 out of 25. You are selling mobile phones. Your boss wants to earn more money. So at first they try to have a price that's very high. They try to increase the price by 40%. Nobody buys the phones, too expensive. And so he discounts that price. He still wants to make money though. So even though he increased by 40%, he only decreases it by 30%. Now, what percent of the original price is the phone now? On this kind of question, the usual best way to try to handle a question like this is to say, what does it mean to increase a price by 40% anyway? If you increase a price by 40%, then what you're actually doing is you're multiplying the price by 1.4. Okay, but then in that case, what happens when you decrease the price? If you decrease the price by 30%, then you multiply by 0.7, because that's 70% of the price is left. So now I need to multiply 1.4 and 0.7. Actually, these are numbers, again, chosen very carefully. In another another problem we talked about on the AMC8, we saw 7 times 14 already come. This was the number that was very close to 100. So actually, 7 times 14 is 98, with 2 decimal points here because of the fact that each of them has a 1.4, 0.7. So actually, this is kind of interesting. When you do the whole thing, the net result is that the price is 98% of the original. So even though the boss thought that he wanted to make more money, he thought maybe increase price by 40%, decrease only by 30%, actually the price is lower than what it was when he started. A little bit about the theory of this is that actually whenever you have an increase, if you want to offset or compensate for a decrease, you actually need a much, much bigger increase. Here is an extreme example. Suppose that you decrease the price by 100%. Then how much do you need to increase it by to get it back? Well, you can't. If you have decreased the price by 100%, you're already at 0. So this shows how the decrease is actually a much bigger effect than the increase. And so when you're looking at this, one way you want to work on problems is you want to check to see if the answer makes sense. And if it seems like, in this case, it seems like the price is lower than it was before, even though the 40 is bigger than the 30, the thing to keep in mind is that the power of the decrease is much bigger than the increase. And so this problem brings out the ideas of multiplying these multiplying these decimals to represent the percents, but I wanted to review the 98, which comes very often, as well as this philosophy about increase and decrease, and the fact that it often actually ends up less than it was before.